And here I also want to plot the vector field for the unstructured data, but different from contour and contour F, we can still use the quiver function, Barbaras function, and the stream plot function for the unstructured data. So for example, I first prepare the 10-meter wind data from the data set first. And if you remember from the previous tutorials, we cannot plot all the data points of these wind speed because it will be too dense for the arrows to display on the map. So you need to select part of the data to plot in the map, okay? And for unstructured data, we also do the same. So these are my own way to select the data in the unstructured grid. So basically, so I just first define the coordinates that I want to add the wind arrows or the wind barb. So I basically want to maybe in every 9 longitude, I want to add a wind barb, and in every 9 latitude, I want to add a wind barb or an arrow. So in here, I want to know the coordinates of these coordinates that I have specified. So so in last cell and long cell here, these are the latitude of each of the cell, right? So I need to know which is the cell that has the coordinates of these. So I need to find the dimension n cell. I need to find the position of the index to find the cell that has the closest distance to the coordinates that I've specified. So basically, I use this method. So here, here you can see I have something like a long cell minus x, and then it helps me to find the distance between each of the cell and the xy that I have specified in here. And this function is used to help you to find the index of the minimum. So this is a bit hard for me to explain. So for example, I have x, maybe I have a 90 longitude, the longitude of 90, and then I have a latitude of 0. And if I apply this thing here, this is basically an array that tells you the distance of each of the cell to this xy point, to this longitude and latitude position. So these are the not really distance, but it's not a physical distance, but it's also a kind of distance, okay? And this argument is used to help me find the minimum of the value, the index of the minimum. So if I apply this function here, so this is the index that has the minimum value. This is different from just mean here. If you use mean, it really finds the minimum value for you. So the minimum value is like 0.17 here. But if you use arc mean, I think, oh, okay. Yeah, I mean. So if you use this function, it will find the smallest index. I mean the index, the position of the smallest cell. So when you just use this. Can I do this directly? Actually, oh yes, I can. So this is the index. So this is the position of the cell, and then in this cell, So this cell is basically has the smallest distance to this point. So I just find all of those things in these coordinates. So this is what this piece of code is for. And I generate a bunch of index here. These index represent the cells that are closest to the arrays, the points array here, the coordinate arrays here. And then I generate a figure here. So these are basic lines. And then here I apply the index here, the list of index here. So it only plots the cell that has these positions here. So you can see this is the resulting plot here. And this is okay. So for this example, I don't want to do a global quiver plot. I want to do maybe a regional quiver plot. Then I would have to change the step that I apply. So I have to change this step that I have to apply. And here I just use a kind of a soft-coded approach to do it. So, because I have defined the latitude range and the longitude range of this map, and then I want to know what steps do I apply so that the quiver plot looks nice and the arrows will not be too dense. So I just use kind of tested a bit and then find these steps here. So you can change it by yourself anyway. So these are the coordinates that I want to apply. I want the function to draw the wing arrow. And these are the same codes here. And I also want to introduce another thing here. So you can see the star sign here. And if you run this here, okay, I think it needs to be integrated in a function, in like an operator or something. So when you type long range here, this is actually a tuple. And then a star sign here is used for you to unpacking this thing. So for example, when I type maybe A and B equals to this one, and then I print A. Oh, I think I can do this, but it's not. You cannot do this here. Well, so never mind. So basically, it helps you to unpack this thing. So basically, it's the same as 90, 130, and then 15, and then 35. So this thing is basically the same as this thing. So I just want you to know what this star sign is here. So I think it only applies in maybe a square bracket or maybe a function. It cannot apply directly here. Yeah. And this one, I want to make it maybe as an exercise for you. You can do it by yourself. So you can explore the stream plot and the wing barb as well. So the mechanism is basically very similar to quiver plot. And of course, you can use those functions to plot your own simulation results, because our simulation results are all in unstructured grid. And yeah, you can make use of those try functions to plot your own data directly.